Hi guys, my name is Greg Giorgis. I'm the founder and CEO here at the Chicane Club. We're South Florida's elite sim racing club and lounge. We do everything from one-on-one training with professional amateur race car drivers through private and recreational events with our members-only club based around simulators. My background is as a race engineer, data engineer, and strategist in professional motorsports at all levels, from Ferrari Challenge, Lamborghini Super Trofeo, LMP3s, GT3s, GT4s, whether it's the data side, the coaching side, strategy side, performance side, whichever side it is. I just like helping people go faster. Ever since I've been working as a race engineer, I've pretty predominantly worked with V-Box systems, basically mandated and requested that I wouldn't work on a team unless they had a V-Box system installed in one of their cars. It's the go-to video and data analysis tool, both in the real world and in the simulated world. The video and data we're gonna go through today is actually of me in the driver's seat myself. This happens to be a Spec Miata race car at Sebring, a track that I know very well from the sim, but this is, I've done maybe half a dozen track days here myself. This is a V-Box one camera system that's in a very real world scenario. That's not the full-fledged multi-camera system with a custom overlay and CAN channels. This is a very quick install that I did maybe half an hour before I got into the car. I didn't have any CAN channels, like I said. So we really only have the basic native channels that the V-Box captures on its own based on GPS. So really just speed traces and acceleration. And I didn't have any other driver in the car all weekend. It was just myself, so I don't have another driver to compare to. Again, very real world scenario. But that's not to say that we don't have a lot to learn from this, just looking at my own driving and with just GPS data to look at. What I really like to use when looking at one driver on their own from within one session is the ideal function. So we'll click the ideal. What the software does as soon as you load the session is it automatically will break the track down into a number of sectors. Here at Sebring, it will break it down into 10 distinct sectors based on, usually it's looking for straights and corners independently. There's some algorithm that it does, but it's an all automated process. It'll snip the data into all those individual sectors along with the video. Once it does that, then it can find the best sectors from the entire session and then create what is an optimal or ideal lap. So we have something to look at. If we just simply look at my best lap time, which in this case was a 2:42.1, my ideal lap was a 2:41.53, so that's about a 6/10 difference. Usually it's nice to see from a driver. It means they're consistent when their ideal lap is relatively close to their fast lap time. In this case, we're well into the tenths of a percent. So that's a really, really small difference from my ideal to my best. Doesn't necessarily mean that I'm fast. It means I'm consistent throughout the entire run. The traces that we have available to us just with the native GPS is our speed trace based on GPS position. We have the delta timer, of course, based on any 2 laps that we're going to look at. We have the lateral acceleration, the cornering force, the longitudinal acceleration, the acceleration and braking force, and then the combined G, which is, essentially your G ball moving around, the total magnitude of that G-force combined at any one point in time. One of the interesting things that I would like looking at the combo G, that combined G-force, is that, as in traditional sports car racing, you begin a corner first by braking and slowing down for it. And then you transition through your trailing braking pressure, your release, you load the car into the corner down to apex, and then we continue on power on the exit of the corner until we're back to full throttle, hands somewhat straight again. What's cool about the combo G is that you can distinctly see at first we have on the longitudinal, we have my braking zone here going into turn 1. Then we hit our peak cornering force somewhere near an apex, and then I go back to power. Of course, in a Spec Miata, there's not a lot of power available to us, so you're not going to really see a lot of acceleration force, but at least we can see the braking cornering forces pretty distinctly here. What's cool with the combo G is you can see the transition in total G-force from the braking. At this point here, let's zoom in on this so we got a cleaner look. So here's turn 1. Here's where our peak braking pressure is, and here's where our peak cornering force is here. What's interesting to see is that from the time that we hit our peak braking, quite nearly in a straight line until we get to our cornering force, there is an actual ramp up in pressure. Generally speaking, at a professional driver who's fully optimizing the car, you'll see the peak brake pressure in the combo G at the same magnitude as the cornering force. Generally speaking, cars make as much grip braking as they do laterally. It's a very loose rule of thumb, but it's a really good rule of thumb we can kind of at least work on. What you can see here is that I'm actually braking in a total magnitude of 0.7 Gs, and I'm cornering at my max cornering force at about 1.1 G. So I'm actually generating 0.4 of a G more in cornering force than I am in braking. Generally, what I would take away from this is that I'm not confident enough on the brakes. I probably could have gone a little bit later and deeper. The nature of turn one at Sebring, for those of you that are familiar, it's a very fast entry. It's blind. You can't really see your apex. So that's going to be right here. Let's zoom in, click and drag. All right, so here we can see our threshold braking, my best attempt at doing so. Again, in a spec Miata, naturally I've got 3 pedals. I'm having to rev match, shift gears with my right hand, so there's a lot of work going on just simply in a straight line. And then I transition the car down to apex here at our peak cornering force, and then I accelerate on the way out here. Again, spec Miata, not a lot of accelerated force, but still something we can look at. So the same analysis, again, where I hit my peak braking pressure here, even without having the brake pressure sensor on the car. I can see where my peak braking is, threshold, in a straight line. I'm maintaining a nice job of a really consistent braking force, even with the gear shifts going on. So I'll give some credit to myself. I think this looks pretty nice. And then we transition. It's really the transition from the threshold release braking down to apex through the peak cornering force here. So it's really this period from here to here that I'm going to look at here. And what I see is that I'm not actually losing any combined G-force. I'm simply just making more combined force at apex. So again, perhaps there's some more braking force I could have optimized here. Maybe a little bit additional, maybe I locked up, maybe there was some issue that I wasn't able to get the peak braking force out of the car. But what the key takeaway is that the combo G does not dip or decrease at all between the braking portion of the corner and the cornering portion of the corner. So I'll give some credit to myself. I think I did a nice job of transitioning from the braking phase to the cornering phase is what this really means. So this is a very useful tool, again, without any CAN channels and a very basic set up with the V-Box system here to be able, this is a really nice determination. Overall, my lap, this is pretty close to an ideal lap. I did at my best one. I know this is an afternoon session at Sebring. Again, for those of, like most racetracks, I think Sebring is an exaggerated version of this. At about 2 o'clock in the afternoon, the grip is 4 or 5 seconds off pace from what it is at 9 o'clock in the morning. So I know my best lap was actually from that weekend about 4 seconds faster than this. So, I don't know that a direct comparison to a morning session to an afternoon session. We can certainly look at placements and some correlations, but a direct lap time comparison or some of the forces that I'm generating may not be possible to achieve in the afternoon. Let's look at this. Where's the difference from one of these laps? Here, let's, instead of looking at my ideal to my best lap, let's look at a slower lap, perhaps an earlier one where I was a little bit slower. Let's look at lap 3, where I did a 243.1 against my 242.1. So a whole second difference here. Let's see if there's some differences here. My rule of thumb, whenever I'm just pulling up data, the first thing my eyes are naturally drawn to on the traces is the speed trace. Where is the biggest difference from the fast lap to the slower lap? Again, my red is my fastest and the blue is my secondary lap. My first eyes immediately go here, and I know from looking at this in my recollection, I missed a gear. Going from second gear to third gear in a spec Miata is a very easy one to miss if the synchros aren't brand new. And I can tell you from looking at the video, you can see myself struggling here. I'll let this play through, but I'm sure it's me struggling to get it into second gear. Or excuse me, going to third gear. Yep, there it is. Without even looking at the video, I can tell you I'm fighting to get the car into third gear. So that's exactly what this was here. Not ideal. I think we're having some issues with the synchros on the car for that weekend. So, yeah. Let's see what else we're driving wise. It looks like here, let's go to turn 17. This is an area, if you know turn 17 at Sebring, it's unlike any corner on any racetrack, in my opinion, anywhere else in the world. So, it's got this unique combination of a light braking zone, a turn in, you release the wheel back to straight, you continue your braking, release off, get it turned in, go under the bridge, pick up all the bumps under the bridge, and then you power down on the exit. So, from the beginning of the session to later in the session, you can see that my red lap, my lap 6 versus my lap 3 in blue. You can see just from the speed trace alone that I had more confidence to go a little bit deeper on the brakes here. And you can see that again with the longitudinal acceleration. Even without the CAN channels, we can see what I'm doing with my feet here between the throttle and the brake, that I lifted off much later and then decelerated the car at a higher rate. So more braking force as well. As a coach and engineer, I see this as, I was warming up the car in lap 3. I wasn't ready to fully push. It was a practice session. I was taking it nice and easy. And then through the next couple laps, I built some confidence in the brakes to go a little bit deeper and get more comfortable with everything. So this tracks. The lesson for myself was, If I go back out again, if I were to do this practice session again, the goal is to get faster sooner and to do that more comfortably sooner. So the goal would be, you know, let's not take 6 laps to get up to speed to do this. Let's try to do this on lap 2 or 3, at least as once the tires are warm and we're sure the car is mechanically safe to drive. What I can also see here that's very interesting in all 3 of the traces, I can tell you, before I even click on this or play the video, just looking at the combo G-force, I can tell you this is the bump onto turn 17. The combo G, the lateral G, and the longitudinal G all had a surge. I can tell you, here, let's play through the video. It looks like it happened exclusively on my fast lap. Let's look at what happened here in turn 17. Approaching, I'm gonna turn into 3 cones. I brake right around here, get a downshift down to 3rd gear. I make my turn in, we're approaching this bump, and there it is, right there. Yeah, so if we back this up, we can see just from the traces alone, this big bump pretty much at full load here, exactly where this happens. And we can even slow this down if we really wanted to dig in further into this. I can go all the way down to quarter speed, hit play, and we can watch this in very slow motion. Right where that bump is, you can see me jostling with the wheel. Fortunately, I was on a great damper and spring combo setup that I knew to anticipate this corner, and we were going on a good suspension package. So this is a known thing in this corner, but you know, just something to be aware of, especially if you're driving at something as bumpy as Sebring. So let's go back and look at my lap 3 versus lap 6, and let's look at the line into turn 17. I can see from here there's a little bit of a difference. Let's zoom in on this. So based on the GPS position, we know that we have within, call it 1 foot or 30 centimeters accuracy on this, unless you upgrade to the premium GPS system. We can see the trajectory of the car throughout the corner. You know, this is not insignificant, the difference between the 2 of these, where the car is placed. You can actually even change the icon now, where you can actually visualize in the settings what icon it is. So this car is shaped roughly the size of the car. So we're looking at about half a car width on my faster lap that I was tighter to the inside wall. And when we actually play through the video with this, we'll actually be able to visualize that in real time as well. So again, we're in quarter speed here. I'm going to play it down so we can see how closely I get to the inside wall here, which is usually a mark we're aiming for here at Sebring in turn 17. Let's play it down, and we stop. So as this pauses, we can see very clearly on the video, just as the trajectory line shows here, about a half a car width closer, you can see that on my faster lap here, yeah, I'm getting pretty close to touching this mirror onto this white wall right here. Whereas on the blue lap, 3 laps earlier, I was a little bit more conservative. You can see I'm about a half a car width off. So the GPS positioning is very accurate when it's showing this. So we can see line differences, especially useful when you have 2 different drivers with perhaps 2 different styles or 2 different times of day or 2 different sets of conditions. We can see the trajectory and line differences very clearly. One of the fundamental discussions that all coaches have with a race car driver, especially at the early stages, about where they're placing their eyes. I've done a lot of work here at Sebring in real life, and I've worked with a lot of drivers in the sim world to get ready for this. And I know that the Bishop's Bend to turn 16 section of Sebring is an area we're always talking about eye placement. There's so many errors that are made in this section that all come back to where we're placing our eyes as we transition from the fast right, a bend to the left, and then a secondary right, turn 16. So let's look at how I did here. I see a little bit of a difference in the trajectories here right off the bat. Again, my lap 2, I realized this was probably my tires weren't fully up to temperature yet. For context, and it looks like on my slower lap I had traffic in front of me, which nonetheless is a very interesting thing to talk about with eye placement. One of the things you see with drivers racing in their racecraft very early on, when they're behind another car, they get fixated on the bumper and they all of a sudden are missing apexes. They're in the wrong place all the time. So let's see how I did here. Bishop's Bend leading to turn 15, 15B, and then 16. Bishop's Bend is a very high speed corner. It's really a double apex, big arc, big sweeping arc. Left-hander, immediately into a medium brake zone that I release off the brakes, float the car back to the right, back to the left, go wide off the left side of the track, and then come back for turn 16. That's all to say that this whole section, the most single important portion of it is the exit out of turn 16. As you can see, it leads onto the Sunset Bend, head down to turn 17, one of the longest full throttle sections on the track, which, you know, is going to be really important to get a really strong exit out of. So let's see how I did here. If we just look at the traces alone, we can see that my minimum corner speed, again, we knew this is on a not full speed lap, but we can see that the cornering speeds are already at apex. We're 9 kilometers down, 9 kilometers an hour slower at my minimum speed at 15. And then at 16, I'm again 12, 13 kilometers an hour down at my minimum speed there as well. So definitely some time lost in there. I think that can be explained by the fact that I was on again, still a warm-up lap and wasn't quite there. But let's see how I place the car. That's actually what I'm more interested in seeing here. Let's play through my videos and see how these sync up here. So again, we're bending to the left. We're coming to our braking point here. I'm going to turn into the right. The goal here at turn 15 is that we're trying to get our right side tires onto the curb. It looks like I've got the car positioned really well here in both instances, with the traffic and without. And then I come back to the left. It looks like this car in front of me has a different interpretation of the line here. I'm coming back to the left, way across the left side of the track as we set up a run out of turn 16. Let me zoom in on this. If we look at our trajectory here, it looks like I got a much wider approach on my slower lap and then had a much shallower exit. Maybe again, I haven't watched this yet. Maybe I'm going past this blue car here. Let's see. So I get much wider. I turn in a little bit sooner on the blue lap. And then we can watch my positioning here. Really critical, again, exit of 16. We want to get our right side tires onto the blue and white curbs here as we pick up to full power. And let's see how this plays through here. Yeah. So it looks like what happened, there was a car up ahead that went off. The dust caught my eye and I kept it a little shallow on exit, which explains why I'm in a different position here. Usually what happens here at turn, I'd rate myself that I did a fairly good job here, all things considered. There's probably some pace in using the entire width of the track on the exit, but the dust caught my eye and I was a little conservative. One of the areas that we specifically talk about with our eyes with 15A and 16 is right here. Bishop's Bend leading to turn 15, 15B, and then 16. Bishop's Bend is a very high-speed corner. It's really a double apex, big arc, big sweeping arc, left-hander, immediately into a medium brake zone that I release off the brakes, float the car back to the right, back to the left, go wide off the left side of the track, and then come back for turn 16. That's all to say that this whole section, the most single important portion of it, is the exit out of turn 16. As you can see, it leads onto the Sunset Bend, head down to turn 17, one of the longest full throttle sections on the track, which, is going to be really important to get a really strong exit out of. So let's see how I did here. If we just look at the traces alone, we can see that my minimum corner speed, again, we knew this is on a not full speed lap, but we can see that the cornering speeds are already at apex. We're 9 kilometers down. 9 kilometers an hour slower. Another really good diagnostic tool to check out whether your V-Box is functioning correctly. One of the things I see very commonly is an improper or less than perfect setup for a satellite or GPS antenna location. What we normally want to see for the number of satellite connections to have really high fidelity data, I'm usually looking for north of about 8 or 9 on satellites. Anything north of 10, 11, 12, we've got a really good lock. If I'm seeing 4, 5, 6, 7, either there's an issue with the GPS antenna, there's a solar flare, or really thick cloud cover, or something else is going on that's hindering our GPS antenna. I have actually seen the solar flare issue before, believe it or not. So one of the things I see all the time is mostly from the engineering side. I'll come back to a good GPS antenna location. I see it all the time that someone's got it in improper location. It's set up incorrectly. It's not direct line of sight with the sky, or it's in the car, or it has some sort of occlusion that's preventing it from getting a really strong lock. And it's very clear. The first thing I do is I'll pull up the channels tab here. I'll select the satellites function, and then we'll look at the channel down below here. And just very quickly looking at this, you can see on here, let's just look at one of my laps, for example. I'm really operating almost the entire lap above 10 satellites, and there's a brief moment here, right as I go under the bridge at turn 17 at Sebring, where I have a drop to only 8 satellites. Generally speaking, the rule of thumb is that I'd like to see more than really 8, 9, 10 satellites on average throughout the entire lap. If we're 11, 12, 13, 14 satellites like that, we've got a very, very high fidelity lock for positioning. But if you're operating with 3, 4, 5, 6 satellites really in that range, or even lower, 1 or 2, there is very little fidelity with the actual GPS position. And because of the way that the Circuit Tools platform uses the GPS position as a x-axis value, if your GPS satellites, if you have low fidelity with your satellites, it's very hard to correlate data correctly, especially between 2 different cars with 2 different GPS setups. The other great way of looking at this is the Reports tab. I've already got it pulled up on the Satellites channel. and I use the automatic features for this, you can see that really 99.7% of my lap, I'm operating with at least 9 satellites, and most of that time is spent with 10 or more. So I'm personally really satisfied with the number of antennas I have here. But if you pull this up and you see you're operating with 4, 5, 6 for satellites for 80% of your lap or more, there's something you should do to improve your satellite connection. I know RaceLogic has a number of support articles on their website that detail exact ideal location, how to place it, and all the tips and tricks with how to set that up correctly. So this is another great diagnostic tool to figure out why there's some fidelity or correlation issue. All right, well, thank you for joining us today. It was really a pleasure to share with you, breaking down some of my own driving and a spec Miata here at Sebring, and working through the full workflow with Circuit Tools 3, with even a fundamental one-camera setup and no CAN channels available. There's a lot to learn just looking at one single driver without CAN channels. There's really the possibilities and the flexibility of Circuit Tools 3 is unmatched. My name is Greg D. Giorgis. Again, I'm the founder and CEO here at the Chicane Club. You can find us on the web at www.thechicane.club. Yeah, it's been a pleasure hosting this for today. Look forward to doing more of these videos with you guys soon.